grade 11 students, welcome back to the Physics of Music Part 3. I hope that you and all your family are fine and safe. Today we are going to talk about how we can calculate the frequency in both open pipe and closed pipe. Here, for example, in open pipe resonator, and as you see, I have antinodes in both ends. So in this case, the equation is going to be given as the following. Fn equals Nv over 2L. Now, N is any number. We said at the beginning that the fundamental resonance or the first harmonics happens when N is going to be equal to 1. So when I'm going to substitute 1 instead of N here, so here I'm going to have F1 equal 1 V, and V is the speed of the sound, divided by 2 times L, which is the length of the pipe. The same thing if I'm going to substitute with 2. In this case, it will be F2 equal to 2V over 2L. Now, in the open pipe resonator, I'm going to have the first harmonic. This is the fundamental or the first harmonic. And I'm going to have the second harmonic, and I'm going to have the third harmonic. So in this case, the open pipe is going to resonate. Let's talk about the closed pipe resonator. In closed pipe resonator, you see here, I have anode and here antinode. This is the first harmonic. Now, this is the third harmonic, and again, node and antinode. Here I have the fifth harmonic. Also, I'm going to have a node here and antinode at the end. The node, because in this case, it's a reflection from a fixed boundary. This is why it's going to be inverted. Now, as you see, the resonance in a closed pipe happens only when N, which is the number of the harmonic, is going to be an odd number. If it's an even number, in this case, the resonance won't happen. This is why we don't see lambda 2 or the frequency 4 or any even number, because the resonance happens only when N is an odd number. Now let's practice some problems. We have this problem and additional in-class examples. We don't find them in your book. So this is why this one is very important, because you don't have them in your book. Now, here we have a pipe organ has an open pipe with a resonating height of 9.75 meters. Ignoring and correction, what is the frequency of the longest sound wave produced by the pipe? Assume that the speed of the sound is 343 meters per second. So, first of all, I have to find out, is it an open end resonator or it's a closed end resonator? As you see here in the question, it's open end resonator. Now, we have here 9.75 meters. So from meter, I would know that this is the height. And here they're saying what is the frequency of the longest sound wave. So in this case, they are asking me to find the frequency. The frequency is unknown. And then finally, I have the number 343 meter per second. And from the unit, I would know that this is the speed of the sound. So now let me just put the givens. Okay, so since it's an open pipe resonator, in this case, the wavelength is going to be 4L or 2L. In this case, it will be, of course, 2L. Lambda equal 2L. So as you see here, lambda is equal to 2L. And again, I have to substitute by L. So L is equal to 9.75. I'm going to multiply 2 times 9.75 and I will get 19.5 meter. Then I will move to the unknown part, which is the frequency. The frequency equals the speed of the sound divided by the wavelength. The speed of the sound is already given here in the question. So I'm going to put 343 meter per second divided by lambda, which is the wave length, which I have found it here. So I'm just gonna put it here. So 19.5 meter. And I will get 17.6 hertz. Now this is a small practice for you. I want you to solve it and then try to post it to me. Now, let's read the problem. A musical instrument has a closed pipe with a resonating height of 8.2 meter. What is the frequency of the longest sound wave produced by this pipe? Assume that the speed of the sound is 333 meter per second. Again, try to solve this question on a piece of paper, take a picture of it, and then send it to me through either Horizon portal in the Communicate, or in this case, if it's going to be on Microsoft Teams. Thank you so much, and I hope you understood the lesson. And if you have any inquiries, you can just communicate me. Goodbye, and see you again in part 4.